Today we're going to be teaching you guys about Lewis diagrams for molecules that contain no charged atoms. We're going to be using the example of CO2, which is also called carbon dioxide. It contains one carbon atom and two oxygen atoms.
The first step is to find the valence electrons of the molecule. To do this, first you find out the number of valence electrons in each atom, and then you add it together to get the total valence electrons. In this case, we have the carbon has 4 valence electrons and oxygen has 6. So to do this, you have to add them. And since oxygen has there's 2 atoms for oxygen, you have to multiply 6 by 2. So when you multiply 4 plus 6 times 2, it'll equal 16.
So the second step is to figure out how many octet electrons the molecule should have. So each element, the octet rule is that each non-charged element on the periodic table wants 8 octet electrons, except the odd 2, which are boron, which wants 6, and hydrogen, which wants 2. So if we add 8 plus 8 times 2, because there's 2 oxygen atoms, we'll get 24 octet electrons. Step 3.
Now you have to subtract the valence electrons from the octet electrons. So since our octet electrons are 24 and the valence electron is 16, 24 minus 16 equals 8, and this gives us the bonding electrons. Now in step 4, we divide the number of bonding electrons by 2. And when we do this, we find out the number of bonds, which in this case is 4.
So finally, we're going to draw an arrangement of the atoms for a molecule that contains the number of bonds that you found in number 4. Through this process, we must remember that hydrogen and halogens bond only once. The family oxygen is in bonds twice. Nitrogen's family bonds 3 times, and the family of carbon bonds 4 times. So knowing this, and knowing that we need 4 bonds, we can draw oxygen with 2 connecting to carbon, and also from the other side. So now carbon has 4 bonds, 1, 2, 3, 4. This oxygen has 2, and it can only take 2, and this oxygen has 2. So finally we have step number 6, where we find the number of unbonding electrons. We have to subtract the bonding electrons from step 3 from the valence electrons from step 1. So we got 16 valence minus 18 bonding, which gives us 8 unbonding electrons. So now if we go back to this diagram, we can draw them in the 8 unbonding ones. 1, 2, 3, 4, 5, 6, 7, 8. And you always have to draw them in pairs.
Now the only reason why oxygen has these valence electrons is because carbon, all of their valence electron got bonded with the oxygen. But since oxygen only needed to bond twice, the rest of them were bonding together, if that makes sense.
They were pairing up.
Yeah, so they were paired up, and since the other 2 were not paired, they paired with the unpaired ones in carbon. And now there's also one more thing you need to remember. Every time you draw this diagram, the atom that is first in the name, and in this case it'll be carbon, it goes in the middle. And then the other elements, which is in this case is oxygen, goes around it symmetrically. So if by any chance there was 4 oxygens, it would be like this. There would be 4, but there isn't.
You should always try to make it as symmetrical as you can. It won't always turn out symmetrical, but you just have to try your hardest to make it symmetrical. And be careful of all the bonds and unbonding electrons and everything when you're drawing the diagram. We hope that you learned from this video, and thanks for watching. Now we're going to teach you guys about how to draw Lewis diagrams for molecules that contain 1 or more charged atoms. We're going to be using the a molecule NH4, which contains 1 atom of nitrogen and 4 of hydrogen.
Now the first step is the same as what you would do to non-charged atoms. You have to find the valence electrons of the molecule. By doing that, first you find out the number of valence electrons in each atom. Nitrogen has 5 and hydrogen only has 1. Then you add it together to get the total valence electrons. 5 plus 1 times 4, because there's 4 hydrogens, which will equal 9. Now, since as you can tell it's underlined, the minus, it's because the polyatomic molecule there's a positive charge on it. So because of that, you have to subtract the valence electron from that. So since there's only one, it'll only subtract one. So it'll be 9 minus 1, which will equal 8. And that'll give you the total valence electrons.
Then you have to figure out how many octet electrons the molecule should have. So just like in the last step, or the last video, nitrogen will want 8 octet, and hydrogen, like we said, will want 2. In this case, since there's a charge, boron will no longer only want 6, it will want 8.
Step 3, subtract the valence electron from octet electrons. Here we have to subtract 16, 8 from 16, so it would be 16 minus 8, which will equal 8 bonding electrons. Now, step 4 is
dividing the number of bonding electrons by 2 to give you the number of bonds. So 8 divided by 2 is 4, so we get 4 bonds.
Now we're drawing the atom. So as we said before, the first atom in the molecule in the name, it has to go in the center. As you see, it's in the center. And then the other atoms go around it symmetrically. So there's 4 hydrogens, like they're supposed to be. And then, as it says here, we need 4 bonds. So there's 4 bonds. 1, 2, 3, 4. And here it says hydrogen only needs bonds once. So that's why there's only 1 bond in each one. And of course, since the octet rule says they only need 2, there you go. They only have 2 electrons. And nitrogen needs 2, 3, or 4. There's 1, 2, 3, and 4. Not over the limit and not under. Now, step 6.
We have to find the number of lone pair or non-bonding electrons by subtracting the bonding electrons from step 3 from the valence electrons in step 1. Arrange these around the atoms until all of them satisfy the octet rule. Since we're subtracting 8 from 8, there's no unbonding electrons.
And as you can tell here, there is no need for them because nitrogen, as it's said over here, nitrogen has 5, but since 1 is taken away, there's only 4, and therefore there's
4 more electrons to fill it.
4. But it'll also explain a little bit more when it comes to this step, which comes to the 7th step, which pretty much explains why there's only 4. Since nitrogen, step 7 is to find the charge on each atom, compare the number of electrons that each atom has to the number of valence electrons it usually has. Now, if the number of electrons that the atom has is more than the number of the normal number of valence electrons, the atom has a negative charge. If the number is less than the normal number of valence electrons, the atom has a positive charge. If it's the same, the atom has no charge at all. And since nitrogen had 5 to begin with, and it only has 4 bonds, then there's a positive charge to it. So since there's only, there's less than the normal number of valence electrons, it has a positive charge. So therefore, this is how it would look with the positive charge.
So that's it. If you guys have any questions, feel free to ask us. We hope you enjoyed these videos and they were helpful to you. Thanks.